Unit testing in software engineering or testing, verification, validation is a phase, is a testing where we test a unit, a piece of code which work as a unit. That is why unit testing. So unit testing can be, you are testing say web content, you are testing a component, you are testing a function, you are testing a procedure, you are testing a class. If they are working as a unit and you are testing it, this is unit testing. Most of the time, the unit test cases are written and unit testing is performed by developers. So you are trying to check the behavior of the function or the class what you have implemented. So this is the one of the basic testing, which every testing starts from here and it comes under white box testing. So unit testing is focusing on verification. That is, you want to test whether your software component or a module is working fine. The coding, the part, the construction you have done is what you have intended. And it is the smallest unit you can check. And in this unit testing, we do a lot of activity. For example, you have a function called add. Now this function, they may have, or you might have written number of control paths. For example, a lot of if else's, a lot of while, do while or switches. So there can be multiple control paths. In unit testing, all these control paths should be at least once be traversed. Okay. And second thing is boundary value testing. That is, for example, you have given 0 to 100. This is what you have to enter. But if the user enters 101, what will happen? So this is the boundary. So at the component level design, control path and the boundary value are tested in unit testing. These are the basic things. Along with this, whatever computation part or internal processing logic you have written or the data structure you have used, say array or a linked list, how does it work? Does it work fine? For example, array always start with the 0 and with a number which is n minus 1. And because you are testing or checking the component on the basis of unit, you can conduct this unit testing parallelly. Whenever we are doing the unit test, there are certain considerations. Because as a developer, you need to know what you are going to do. First of all, there are modules you are testing. There are functions you are testing. And these modules are not working independently. They are going to work with some or the other component or the module. So the module interfacing is very important. How the data is going out, how the data is coming in. So as a program unit, the data inflow and outflow has to be tested. So interface has to be checked properly in unit test. Then whatever data structure you have used, because in a module or in a unit, you might be using the data structure, which is local data structure. So you are using linked list or a stack or whichever. The data which is stored here or the data which is manipulated here should maintain its integrity. It should not be manipulated by itself. Then, because in a unit there can be multiple control flow path, it can be if else, it can be do whiles, it can be switches and many more. So all the independent paths should be exercised at least once, should be checked at least once to ensure that all the statements in a module have been executed, have been tested at least once for the expected result, what a developer is expecting. So these are different paths. Every path needs to be checked. The next part is the boundary value. Boundary conditions are always there because we want to limit or restrict the processing. For example, angle. Say example of latitude or longitude. Say example of latitude. The latitude always varies from 0 to 90 and 0 to minus 90. Okay, from the 0 equator to the north pole 90, to the south pole it is negative 90. If someone is entering 91 or 89.9, this boundary, because most of the software or the code fails at boundary conditions. So now this, whatever is happening, good is good. But if some error is there, some problem comes or user doesn't choose a scenario which the developer is expecting, there has to be some error handling also. So this error handling path also need to be tested. The error handling should be checked for error, and data flow across a component interface should be tested. If the data is not entering and exiting properly, the other tests are simply a moot. They are controversial. They are not to be believed. So interfacing the data going out and in this is the basis of your unit testing, because ultimately this unit is going to be tested with other units. So the local data structure which you have used, it may be possible that when you combine it, when you go with it, there can be global data which may have some impact on the local data structure, and that need to be exercised, that need to be executed as a part of a unit test, right? So local data structure along with the global effect, this is also a part of your unit test considerations. The test cases, what you will write, what you will put here, these are designed to uncover errors due to certain erroneous computation. For example, if you have written A greater than B, maybe you should have written A less than B. So there can be incorrect comparison, there can be improper control flow. If you want the control flow to be like this, you have actually written in another way. These are the basis of the test cases for a unit test. Let me tell you: interface checking, local data structure, boundary conditions, independent path, error handling path. These are all the part of your unit test considerations. This is how you write the test cases. As I said, in unit test, boundary value or boundary conditions are very important. So boundary testing is one of the most important unit in unit testing, because software generally fails, your code will generally fail at the boundaries. For example, this is an array. Now, if you want this array, how are you going to define ARR array or some name and then 100? Now this 100 is seen. Now you will be tempted that 100 should be used somewhere, or maybe. But the array, it always starts with the 0 and it ends with 99. 100 will never be reached. What if someone or your program tries to access 100 or 101 or value which is beyond the scope of this array boundary? Okay. So that is the problem. That is, we need to check at the boundary. Most of the time, the repetition of loop, sometimes you are accessing the loop. You know that the loop should be like this, but maybe because of some error, you have exceeded the loop. So the number of times the loop is working properly, it is okay. When it goes beyond the scope, there will be an error. So the maximum or minimum allowable value, whenever it is encountered, it should be checked. I'll give an example. If you are entering an age and the limitation is 21 to 65. So there can be multiple test cases you are going to write. Invalid test case, if somebody puts 20, there will be an error. And it should show the error. Invalid test case should be 66 because it cannot go beyond 65. And the valid test case is in between them, like 21, 22, 65, 64. Under this unit test consideration, a good design always anticipates what are the error condition and what are the way to handle these errors. So there should be, normal code should be also included with the error controlling path. For example, 21 to 65. If your age, say, is, I'll just writing a code to check. The age is greater than 21 because 21 is included, so we'll put a equal also, or you can write and also. Age is less than 65 because this 21 and 65 are inclusive, we will put a equals to sign also. Now this is a valid condition, but there has to be some error controlling also. If this is not done, what you are writing in error, in else, what you are writing, that needs to be checked also, because the error should be whether something goes wrong, it should be going to the reroute you have written, and the program should terminate very clearly whenever the error occurs, because error is not about about retry done blue screen. It's all about handling it properly. So Yoden says it as anti-bugging. Anti-bugging is all about identifying the error location, analyzing the actual error, prove the analysis, and cover the lateral damage, because error may create damage. You need to cover it also. That is anti-bugging. The code which normally does like this, good code. So if error handling paths you have implemented, the error has to be tested for its own error. So potential error to be tested when error handling is evaluated. Whenever you are testing the error handling, what can be the error in error handling? What are the potential errors? See, I'll give you one by one. Sometimes the error described by a developer is unintelligible. You cannot understand what the error is. Error noted does not correspond to error encountered. With the error is coming is not at all the error you know that it ought to come. And the error condition causes system intervention prior to error handling. That means this error is not achieved before that some error has come. An exception condition processing is incorrect. You wanted to handle something else, but you have done something else. Error description does not do anything to assist the location of the cause of the error. It's all about finding the error. So if you're not able to locate, there is no point. These are the unit test consideration, because you have to check the error condition also for errors. Under the unit test procedure, unit testing is considered as an adjunct, as a help, as a party to the coding step. That is, whenever you are doing the construction, the unit testing is a part of it. They are considered to be adjunct to each other. So unit testing design can be done, or can be, because you are talking about test design. I'm not talking about testing. Unit test design can be done before the code, after the code. Both ways you can do. So unit testing is all about testing the code as a unit. So each test case should be coupled, or should know what are the expected results. So whenever you make a test case, there is a proper template. That is the brief, the test case, use case, the preconditions, the post condition, the error, the exception handling. So you need to know what are the expected results and what is the actual result. So because a component is not a standalone program, don't think that if you have tested a unit or a component, everything is okay. Because it is not a standalone program. You are going to combine it with some of the other component. Maybe that component is developed, maybe that component is not developed. So a component is not independent. It will work with some or the other, because the data flow and the interfacing will be there. So when we combine the module, there is a different kind of testing we do. But here, when we want to test a single component, we have to make for unit test driver and stub. Driver is what? Driver is the main program which is calling your module which is unit tested. That is, a driver is a program which is going to invoke or call your actual component you are testing right now as a unit. But this unit or this component may be invoking some other code also. So driver is a main program that accepts the test case data, passes these data to the component which you are testing actually, and it may give the result or print relevant result. This is the driver program you need to write for unit testing. Stubs are what? These are dummy sub-modules or sub-program, because these are the sub-program which are being called by your module being tested. So these are the modules that are subordinate or invoked by the component you are testing. So driver is the main program calling your module, and your module might be calling some other code which is the stub, right? So this driver and dummy are very important, and these are overheads because they are not doing any other work, but you are writing it in order to check a unit, a component or a module. So both must be coded, need to check for unit test, but you need to remove it before delivering the software. See, many components you may not be able to unit test because the making of overheads, driver and stub is not so easy. You don't want to make it either. So testing can be postponed. Sometimes the testing can be postponed until the integration testing, when the drivers or the stubs can also be used. Maybe you won't be using, or these drivers and stubs are already ready. But sometimes you need to postpone it also. Most of the time people make the driver and stuff and then test their component.